We are discussing about tables, and so far we have discussed the map framework, handling tables, and one important class we have discussed about HashMap. There are few more what is called the utilities are there in this java.util basically to dealing with tables. They are basically TreeMap, LinkedHashMap and EnumMap. So, we will discuss all those things. They are basically the similar to HashMap actually, but better if we can discuss those things and illustrate the different utilities, the method those are there in these methods. Now, let us first discuss about the TreeMap class. Now, TreeMap class, first how we can create a TreeMap and what is basically the TreeMap and how it is different from the HashMap. So, from a programmer point of view, absolutely you do not find any difference between the two, HashMap and TreeMap. They are basically same. All methods, all program that we have exercised for the HashMap can also redo for the TreeMap also. But internally, how the objects are stored in the form of a table or what internal data structure is used, that is the totally different, and it basically remain hidden and programmers should not bother about it. So, what we can say that HashMap use maybe array list type of data structures as a collection, and here TreeMap use the tree type structure as a collection. So, it basically is a storing mechanism which basically Java virtual machine follows in order to facilitate the table to the programmer. Anyway, so TreeMap objects can be created by many constructors. I have listed few important constructors here. So, the first constructor, the TreeMap, it is a default constructor. So, it will create a default value, initially it is empty we can say, and then TreeMap can be created with giving another comparator class, because a tree is required to create a comparison. So, comparator method for string and wrapper method comparator is defined, but some other user type the comparator method to be defined. We have already learned about how a comparator method can be defined for this one. So, it is basically that constructor can be called to create a tree map where the comparator can be defined like, and here is basically you can create a tree map giving already existing map to it, and that map can be any type, whether it is a linked map or it is a hash map, no issue, it can be, not necessary to be passed any type. So, that is why the generic it is defined there. And here this is another example, that if we pass the sorted map, then also a tree map can be created. So, any map, hash map or linked hash map, here the tree map can be created with using sorted map already available, then all these things. So, having one map can be created another map, this map is contains in other map actually, this is the concept, it is there. And so, this TreeMap method does not have its own method define it, all the methods which are defined in the interface map and then sorted map are implemented in this class also, and all the method those are there in, and TreeMap is also extend abstract map. So, this way all methods those are declared in map interface are implemented in this class. Now, let us see what are the different way this TreeMap object can be created and how they can be utilized in the program. So, we will just simply give a simple illustrative program. Here let us look at the first program in this study. This program basically gives an idea about how a tree map as a container, that is a table, can be created. So, here we create a tree map, the name of the container is TM, and here the key is of type string and object is of type double. So, basically this is the key object here, and we just you see it is the same fashion as the earlier one, same, only the put method those are defined we have used for the hash map, right. We can use the same put method is for the TreeMap, but their implementation is different, whereas the hash map the implementation is different, those are internal, you do not have to bother. So, here just we use in lieu of hash map we are using TreeMap, that is all, other things are very same, very similar, common. So, no issue there. Now, here actually set we have already used, that means it basically create a collection of set using entry set, that means all these elements will be stored as a set collection. set will be discussed in details in the next lectures actually. Now, here is basically traversing. So, it basically using the for each loop we create this one. Okay. One important thing is that this for each loop cannot be directly applied to this table, because they are basically for mapping only. Mapping cannot be implicated to this one. So, that is why we have to store this as a set, and on the set we have to traverse all elements in it. So, this is an example so that how a TreeMap container can be created and it can be viewed. Now, let us have another example. So, this is basically same thing, how the get method can be called in this one. So, same methods are there. Now, what I want to repeat it again, all the operations which we have already studied for the hash map is equally applicable to TreeMap. All the programs which we have demonstrated in the last lectures, you can again try with just simply replacing hash map as a TreeMap. This means that all the methods are applicable to the TreeMap only, but internal is different, that is all. Internal means which is faster, all those things other than these things, whatever it is there. So, now let us consider the example of linked hash map. Again it is same as hash map, but storage, internal storage mechanism is different. Now, again let us see what are the different constructors are there for the linked hash map class by which this kind of container can be created. So, there is a default one constructor which basically create a default container which initial size is empty. Now, it can be created having another map that is passed as an argument to this constructor. So, that means it is basically created a new container using already existing container. In it a new container can be created giving as a size capacity, initial capacity this one. So, this is another capacity, can be any integer value. Now, it is also capacity as well as the field ratio, because this linked map like hash map also dynamically grow automatically. As it exhausted its capacity, then automatically it will allocate the memory, but what is the size of the incrementation of the next what is called the enhancement, that can be decided by field ratio. So, 0.75 if you mention, this means that the 75% that you can mention 0.5 means 50%, 0.3 means 30%, like whatever it is there. So, the default capacity is 16, and otherwise it will be increased each time 50% of the existing size of the map, it is there. Now, linked hash map, it is also can be created by mentioning capacity, the field ratio and order. So, if you want to store the data in an order, either order is impossible in case of key values, whether ascending or descending order of the keys, you can mention this one. So, order is possible for only for some data type, not for all. If it is so, for numeric type actually it is applicable. So, if it is true, then it basically insert that container will be maintained in an order. If it is false, it is not in order, it is basically first come first serve basis, as in the order of insertion adding it is there. Now, let us consider example illustrating the concept of this method, it is there. I have given a simple example to understand it, and this is the example, just you check it. This example basically tell how using this class linked hash map a table can be maintained. So, I defined one variable, it is called the max, is a size, it is basically size of the maximum size of the table, in that case 6, you can mention 60 or 16, whatever it is there. So, initially I defined this is the maximum size of the table will be 6. Now, we create, here you can see this is the one way we can creating the linked hash map. You have created, it is a pair, is the key is type integer, object is type string, name of the container is LHM, which is called the of type linked hash map, and here we just call this constructor here, remove eldest entry. I will discuss about this method later on. Actually, eldest entry means it will basically decided whether the eldest entry that is there will be removed to accommodate the next entry or not, depending on this method if we overwrite it is there. So, here basically if size exceeds this matrix, then this method will be called, I mean this remove eldest entry method, that means the first entry, that is the oldest entry, will be removed, so that it can accommodate the new entries. So, it is sometimes useful because all old objects are not so much required. So, we can remove automatically. So, using this method we can automatically remove the oldest entries by the new entries like. So, it is basically just like link means, it is basically whenever we add new elements, it add at the end, and at the same time it basically remove the front element like. So, this concept, it is basically remove eldest entry method that can be. So, here we are creating this linked list with this criteria, decide it. If we do not use it, then it automatically default that it will not, it will, if size is limited, then it will stop it there. So, this concept, it is there. I have just given an idea about if we can have this kind of features into it, then we can redefine or override this method, it is there, where we have overridden that it is there. Now, let us have some continue this program again, so that we can understand better here. So, this is in continuation of the previous part of the program. We just add few elements, we have mentioned the size. So, we already reached the maximum size. Now, here if we put the next element, then it will basically, you will see the first element will be removed, this element will be removed, because this is the eldest element and it will add it on, and then if you print, you can see that it will print up to these elements, it is there. Then again 7, it will remove this one, then next element it will be added, and so on. So, this basically tell that how automatically popping will takes place when you push some element into it, and this is the new characteristics in the linked hash map. It is not available in other class like hash map or TreeMap like. So, this is about the eldest method that we have defined. Now, let us consider, we have discussed about all the simple objects, that is their string and then maybe integer, double, this one. Now, we want to see whether user defined objects can be stored in the table, which is more realistic there. So, this next example will give an illustration where you can define your own objects and those objects can be stored in a table. Let us first define the objects that we want to store it. So, here we define one object called the class book. So, it has few field like, these are the fields, and this is the constructor to initialize the objects. So, this is the declaration of an object. Now, we want to store a few objects of class book into a table, and then we can use table either hash map or TreeMap or any type. I will give you an example using a particular type, it is called the linked hash map only in this case, but you can repeat the same example using hash map or TreeMap or sorted map also. Now, let us see how we can create few objects and add it into here. It is very simple. First we create, here you note, we create integer, this is the key, and book, this is basically the object which we want to store. So, this is the key object pair, and this is the type of container is the linked hash map pair, and this is the name of the container, it is map in this case. Now, in this case we create 3 objects, book, B1, B2, B3, and all those 3 objects are added into the table in the next few statements. So, the objects are added into this map. Now, here traversing is the map using for loop. Here you see we just using the map entry set, so that the set is created here, and for each entry into this one we just get key and then get value, and then we just print the results here using this one. So, for each objects that will be there, we can be created there. So, this basically gives an idea about how user defined objects also can be stored, and this is one simple example that we have given how the different objects can be accessed or it can be traversed. There are many ways it can be retrieved also. Using get value get key is the method that you can consider, or get and get method also you can create. You can pass the get for a particular integer. Here integer is basically this one. That means every objects are mapped with these are the key value it is there. So if you want to particular get, so get for this object map dot get 101, so it basically access this book object to you, and these are the idea about you if you want to access a particular object like this one. So this is example is basically tell you how your table can store your defined object in it. Now this is the last one topic that we want to discuss about. It is called the EnumMap class. EnumMap class, it is of to store the enumerated type. You know the enumerated type is basically some elements that is of enumerated. Now this there are three constructors that you can create in order to store the enumerated type of objects into table, and this is the first constructor that you can consider, where this class basically represent the enumerated type, and here is the another map, existing map can be added into the newly created map. If you want to that you can do it, and this okay, so this is the existing map, okay, and another also existing map, but it basically with upper bound that can be limited to this one. So these are the three different constructors can be used to create a table of type enumerated, and it does not have any its own method. All methods which are there in abstract map, it is also available there. In return, basically all methods which are defined in the map interface is basically are implemented in this enumerated class. Now let us have some examples so that we can understand this concept better. So here is an example. It basically gives you how a enumerated class type of container can be created. So now here we define enum class. This basically here you see public enum. This is the keyword that is there to define the enumerated type, and then size is basically the enumerated set actually, right? S, M, L, X, these are the enumerated elements which belong to this enumerated class, okay. Now here you see we create a container of type enumerated EnumMap. So name of this container is EnumMap of type this one, and here we see the set of key values will be limited to these enumerated sets. So this is the size, this is the set of keys, that means set of keys will varies from S, M, L and X within these sets. If it is integer, it can varies from any values, but here we limit to this enumerated, this one, that is the different. And string is basically the objects, type of objects. Now here we add few entries into this container, our newly defined enumerated map container, and you see the put method which is already used for other classes in this category, we have used it. Then we just created. Now you see we pass the value size.s, that means this class size.s, this is there, and then this is basically the string object that is there. So this basically create a table with enumerated value as the key, and then we can just simply size, and then we can have the print of all the tables. If you want to have, you can print, and then particular key value if you want to print using get method, it basically get size s, that means this value will be printed, children will be printed. So these are the basically example by which enumerated method can be used to store enumerated type into the table. So here few points that you should note. EnumMap class is a member of the Java collection framework, and it is not synchronized. It is not synchronized in the sense that if you write the multi-threading program using EnumMap, then your program will give the compile time error, because it is not advisable to have the synchronized method for this type of objects. EnumMap is order collection and they are maintained in the natural order of their keys. For example, EnumMap defines S, M, L, X, in that order it will be basically stored there, and this is basically very highly performed on data structures for the table maintenance compared to HashMap or other structure actually. All keys of each EnumMap instance must be key of single enum type. That is one important concept that is there. All key values should be of enum type only. And EnumMap does not allow null key to be added into the sets. If you add null key, then it throw an exception called the null pointer exception. So, you cannot create an object or entry using null pointer, it is there. Even null key values cannot be allowed in other methods also. In that case, they also pass the null pointer exception errors there. That means key value should be non-null value actually. It is true for all classes, but it is there also, including HashMap it is there. Now, synchronization is an issue, and whenever we use table, particularly database or whatever it is there, we cannot live without synchronization, because multi-threading is anyway, it has to be there. Now, in case of Java map framework, recently they have introduced a new synchronized, rather it is called the thread shape map framework, it is there. Now, I will just give an example about how the synchronized map set can be created here with few examples here. And to do these things, you see what exactly the new thing that you have to do it. For that purpose, there is a collection class you have to consider here. In this collection class, there is a method, it is called the synchronized map method. So, if you want to create a map, a container of any type, here for example, we are creating a hash map, but it is to be used for the synchronized. Now, none of the hash map, TreeMap, all they are basically synchronized or they are not thread shape. So, here is an attempt that how we can make a thread shape implementation using that map class for the table. So, what exactly you have to do is that you have to call this method while we are creating a new object. So, this is very important. So, if we call this, then that means the map which we will create of any type become a thread shape map. Rest of the things is very same, and then you can use as a synchronized keyword. You can already know about in a multi-threading programming. Synchronized means if we can create more than one thread and then you can create, then it will allow to enter into this object. Here object is map, only one what is called the thread. So, this way it basically ensures the mutual exclusion or critical resource implementation. Now, here in this example, we create a container first. This container is now according to the definition is a thread shape container. Then we create a key sets and then we just simply perform some operations which we want to make, either remove or replace or whatever the operation you can move it under this synchronized keyword you can do it, and then better it can be used it if you call 2 or 3 threads and calling the different methods it is there, and you can call this, then you can see that it is there. But if you use the threads and without this synchronized, then it will give the compile error actually. So, that basically okay, I advise you to have the multi-threading program again. Here we have given this one. So, you can just write a main method there and few thread you can define, and for each thread you can define the run method there, and in each run method all this code can be embedded and you can call, you can see the multi-threading program. So, you have to just exercise, repeat or recall the multi-threading program how you can do it, and then in multi-threading program you just simply use collection as a object. Now, likewise you know all Java collection framework, array, list, arrays, they are also not thread shape. So, that is why you can use this way to make them thread shape. On the other hand, vector, the legacy class is basically synchronized, they are threads. So, you do not have to do it for them actually, which we have discussed details while we are discussing about these things in there. Now, so this is the example that is an idea about how the concurrent programming can be done, and you can check it, and there are few more methods, equals and hasket is the usual thing. So, whether two objects are same or not, that you can check by calling the equal method for the same container it is there. Hash code also we have discussed about. You can override the hash code by for given user defined object, that you can think about it and you can practice it. So, there are many more programs that you can have it. Few more programs you can find in this link. I have given few extra programs also, so that you can check those programs. And the good material, if you want to learn many more other things, the exhaustive discussion that you can obtain from the Java Oracle official websites, this link it is there, and this book also I should suggest you to go through, so that you can study much more. All the programs that we have discussed about in an intermittently you can use for any type of class, and you can create it. And I have given as an illustration only for few 3-4 objects. Instead you can add few more objects into them, very large set of objects, and even you can create a set of objects as an array list or some vector also to store the table and into this one. How it can be done, this left as an exercise for you also. Okay, that means a set of objects are available to you as a collection, array list for example, and we want to make them as a table. How you can do this? So, that idea, just okay, you can find an idea, you can definitely you can get an idea, and then you can write the program. What I want to say, that array list to an hash map container, how you can do, or array list to a tree map, or any other linked list structure to the linked list hash map also. All those things is possible, only the mapping is there. What I want to say is that again, all array list and everything, searching and everything is a non-trivial issue, because they are not efficient. But using this hash map, it is basically store the collection, but it is the fastest in the sense that order of O1, that is a constant time it can be retrieve the elements, and that is the big thing, and it is independent of the size of the table. That is the most utility which it is basically useful. Okay, with these things I would like to stop this discussion for today, and if you have any doubts or any other things, you can just put your question in the collection framework. So, this module is concluded here, and we will discuss about the next module, including the another data structure called the set. Set is a very common data structure. We from class 10 onwards we are studying set, but how this set can be stored as a data structure. In this example also we have used set also, but we will see about the set structure in details in the next module, the module 11, where we will cover set and programming with sets. Thank you very much.